Welcome to the Cyber Operations and Risk Management Briefing, presented by New Zealand's Cyber Team. Today, we will review our research, evaluate alternatives, and offer recommendations. A recent ransomware attack at the Global Economic Summit prevented the availability of essential data for several of the nation's cyber teams. The forensic team was able to use network analysis tools to decrypt and restore the data without paying the ransom. Now, the New Zealand Cyber Team needs to determine possible causes for how this attack could have occurred. The New Zealand Cyber Team needs to evaluate our supply chain, current vulnerabilities, software assurance expectations, and software development lifecycle processes to ensure proper security controls are integrated, which will limit the chances of this attack occurring again. Supply chain risk has been a growing concern for cybersecurity professionals, with recent high-profile attacks demonstrating how vulnerable software can be and the long-lasting consequences different supply chain attacks can have. Threats can occur at any of the stages of the supply chain lifecycle: design, development and production, distribution, acquisition and deployment, maintenance, and disposal. Inherent supply chain risks include limited visibility into the supplier's methods of operation, scheduled delivery and budget prioritized over security practices, the uncertainty of product assurance when the software is deployed based on functionality and interactions with other operational software, and the evolving threat landscape, which could add unknown vulnerabilities into the process. The most common techniques for administering these types of attacks are hijacking updates, undermining code signing, and compromising open source code. Malicious actors can avoid an organization's perimeter security by accessing a network through compromised software vendors. These vendors need privileged access for software product installation. Therefore, if a vendor were to be compromised and credentials stolen, this could allow the malicious actor access into the vendor's client's network. In addition to a supply chain risk management framework, CISA recommends industry best practices like ensuring the vendor's SDLC incorporates security practices at a high maturity model level, provide contracted language that the vulnerabilities are disclosed, patch management capabilities are enabled, and the vendor uses trusted or approved suppliers for its products. We looked at the situation reports to determine if there were gaps in our security processes that could have allowed this ransomware attack to occur. One of the most common vulnerabilities is unpatched software. Vendors are constantly discovering vulnerabilities and push out patches that system administrators need to apply in a timely manner in order to avoid exploitation. Misconfigured firewalls or intrusion detection systems could allow a breach of the network without identifying that traffic as malicious activity. Improper security controls may allow a malicious actor to create accounts without the proper authentication or authorization protocols in place. And finally, the security policy allows USBs to be connected to New Zealand's network. These need to be issued as unauthorized devices because we have no way of trusting the data on those devices like we do for approved assets. According to the Committee for National Security Systems, software assurance is the level of confidence that the software is free from vulnerabilities, either intentionally designed into the software or accidentally inserted at any time in its life cycle, and that the software functions in the intended manner. So, threats to software assurance include accidental design or implementation errors, changing technology environments, and malicious actors. SafeCode provides several software assurance security principles that can be applied throughout the software development lifecycle. These include training on specific technologies, practices, and expectations, requirements defined early with metrics or deliverables at each phase, threat modeling by mitigating risk in a cost-effective way, secure coding, the inspection and authorized handling, security testing, pen testing and vulnerability assessments, documentation, the configurations, testing results, vulnerabilities discovered to assist customers during the maintenance phase, patch management, the security response mechanisms in place, and the integrity verification from the developer. Security principles must be incorporated into each phase to ensure the confidentiality, integrity, and availability of systems and data. During the analysis and requirements phase, we will use the risk assessment to define the classification of data, access privileges, encryption protocols, and segmentation principles. During the design phase, documentation will be provided to describe the architecture, security mechanisms, and what third-party products were used to minimize the supply chain threat. Here's also where we have the threat modeling and risk-based assessments. During the implementation, secure coding practices will be followed while ensuring that the code is free from common flaws found in OWASP's top vulnerability listings. The software will undergo penetration testing and a vulnerability assessment to test for flaws where a malicious actor could find an exploitable weakness. The maintenance phase will consist of adequate security training for network administrators as well as proper patch management plans to keep up with the ever-changing threat landscape. There are several software development lifecycle models that an organization can adopt based on the requirements of the project, which consider cost, timeline, and software assurance objectives. We will outline a few of the more popular models, but for a comprehensive list, please refer to the SDLC matrix and comparison chart in the accompanying report. The waterfall model is easy to follow. It offers measurable development progress, orderly sequence and controls for documentation and design, and clearly defined requirements. The disadvantage is that there's little room for iteration, and there's a large gap between developers and users. Waiting until the software is almost fully coded to test can lead to identifying security problems too late in the process to fix. This lack of flexibility to change requirements could increase security risk with emerging technologies and new vulnerabilities discovered. Prototyping is an iterative approach that allows modifications with earlier user involvement. It's flexible for changing or unknown requirements and experimenting with different design solutions. It identifies functionality concerns early. The disadvantage is that there is no strict timeline or approval controls. The documentation is inadequate due to changing requirements, which limits future potential, and this can cause issues in the maintenance phase, and the iterations can be costly. The spiral model enhances risk avoidance by focusing on small segments to determine objectives, identify risks, and develop deliverables. But without established requirements, there are no controls for moving to the next cycle, which increases the risk of increased cost and schedule delays. New Zealand currently uses an agile model, which is an iterative approach that adds adaptability to incorporate changes to release products quicker and emphasizes user interaction and developer creativity. It is useful for corrective maintenance, and there are cost estimations before each iteration. The disadvantages are that it is challenging to predict cost and resources early. There's limited documentation and fragmented output with no finite end, and it's difficult to track progress. The limited documentation can cause issues in the maintenance phase, and the holistic project cannot be budgeted. To mitigate these risks, New Zealand should adopt a DevOps methodology, which is a combination of the Agile and Lean methods, which places value on collaboration between development and operations staff at all phases of the process, but also eliminating waste to deliver products faster. The continuous delivery offers flexibility for improvements and an ease of maintenance solutions for personnel involved in each step. It values automation and can involve less skilled developers without compromising security. The disadvantage of this approach is that it definitely requires a shift from the normal culture of silo roles to a collaborative approach. New Zealand software assurance goals are to reduce the exposure of controlled unclassified information, maintain connectivity and access to data, and minimize costs while maintaining schedule. To achieve these goals, the New Zealand Cyber Team provides the following recommendations. For the supply chain, to mitigate risks, the organization needs to choose increased maturity level suppliers to provide confidence in the security of a product. The contract language will include assurance of a certification package containing documentation, requirements, test results, and a statement attesting to no malicious code has been inserted into the product. It will also include the disclosure of any discovered vulnerabilities and list all third-party software used. The most cost-effective recommendation is to fix the current vulnerabilities by implementing the following solutions. From a process standpoint, all vulnerabilities should be patched through an automated update system to reduce the opportunity for exploitation. The timing between patch creation and implementation may potentially impact mission, but temporary workarounds could ultimately impact functionality. New Zealand has a schedule to release patches on Tuesdays in order to mitigate the risk of timing, prioritization, and testing while having the least amount of impact on the end user. From a people standpoint, the organization needs to ensure the proper training for cybersecurity professionals to eliminate accidental risk and strengthen defense capabilities. From a technology perspective, administrators need to deploy signatures to detect the indicators of compromise for attacks like this one. For software assurance, the organization needs to shift from reactive to preventative security. Security needs to be prioritized in projects from the beginning instead of add-on features later, or disregarded until an incident occurs. We want to prevent incidents and costs incurred, not just react to them. Ideally, software should be tested and all errors eliminated before it is deployed. However, exhaustive testing of software is impractical and not cost-effective. Risk-based testing identifies and prioritizes risk based on levels of threat, impact, and mitigation costs. It thoroughly tests the areas of software that are at the highest risk, thus ensuring that the most threatened areas of the software are the most secure. And finally, for the software development lifecycle, the DevOps model is not only our best choice for development, but also for the maintenance phase of the lifecycle. Because of the collaboration and automation during development, this will save resource, training, and technology costs during all phases of development. We will have a phased approach to rollout so as not to disrupt business operations. The developers and operators involved in the early stages of the lifecycle will be able to seamlessly respond to maintenance phases. They will focus on how the code software might behave due to unintended user actions, correct those potential errors, and adapt for additional modifications that may be needed that were not a part of the original requirements. New Zealand will need to continue to conduct assessments of the threat environment because the initial risk-based decisions were only valid based on the environment at the time of the deployment. These upfront costs for these recommendations may dissuade management from implementing secure solutions, but remember, a preventative cost-benefit analysis is more challenging to calculate than the cost of responding to an incident, which often far exceeds the upfront costs. That concludes today's Cyber Operations and Risk Management briefing. The New Zealand Cyber Team would be happy to answer any questions that you may have. Thank you.